Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 45 of Physics 5054. Ladies and gentlemen, we started yesterday the chapter of measurement of temperature because that is very important for many experiments in science and engineering. So we yesterday discussed the physical properties and the temperature scale or thermometer which can be developed on a particular physical properties. Today we are moving one step further, and today we are going to do constructing a temperature scale. Ladies and gentlemen, when you are taking a thermometer, nothing is there on it. That is a thick wall glass tube outside, not a thick, a thin one. And there is a capillary tube inside that in which you have to select a substance. So whenever you are calibrating a thermometer, how you will calibrate that thermometer? Today we are going to discuss that in greater detail, and that is the lower fixed point and upper fixed point, and how we will divide those lower fixed points and upper fixed point in the capillary tube. Ladies and gentlemen, to construct a temperature scale means to devise a methodology through which we can create a thermometer. Now, thermometer are of different types. Why? Because we are measuring different temperatures at different locations. Some of them are low temperature and some of them are very high temperature. So for different temperatures, we use different type of thermometers. So that is why today we are going to learn how to construct a temperature scale. Ladies and gentlemen, first of all, whenever you want to calibrate or construct a thermometer, the first step in this is to choose a thermometric substance. And thermometer substance is that one which obey a physical property we discussed yesterday. In this case, we are taking length of mercury. That is a physical through which we will construct a thermometer. So choose a thermometric substance. For example, in this case, we are taking the length of Hg of what? We are taking the mercury. You should select such a substance which is uniformly expanding and uniformly it is contracting, and that is the best property of the mercury. So mostly we are using mercury inside the glass thermometers. That is the first part you have to select, and in the second part select two fixed points. One will be at the lower level and what one will be the upper. This is lower fixed point and this is upper fixed point. Now how we will select these lower fixed point and upper fixed points, we will discuss that in these experiment, how to select this. Now, whenever you are selecting these points, keep in mind that two fixed points are the ice point, which is also called freezing point, which is called the lower fixed point at the standard atmospheric pressure. You have to select it with the standard atmospheric pressure. And the second one is the steam point. Upper fixed point is the steam point or the boiling point of pure water on the standard atmospheric pressure. You have to keep in mind these 2 points. One is the lower fixed point and second is the upper fixed point. Now you have to divide the length of this into equal 100 parts or as many parts are required. Different temperature scales are using different values, so according to that value you have to divide the upper left and the lower left corner in equal 100 parts. Each part is called, in this particular case centigrade scale, is 1 degree. So this is the general concept. First you have to select a thermometric substance. Then you have to find that ice point and steam point. Ice point is the lower fixed point and a steam point is the upper fixed point. Then our third and the most important one, to divide the temperature and range between the two fixed points into equal divisions. For example, divide into 100 equal division if we are talking about the centigrade scale. Centigrade scale is also known as Celsius scale as well. Okay, gentlemen, that is the general criteria. How we will achieve these uh, techniques. So we will do the experiment and we will elaborate a methodology for that to achieve these three different steps. Now, our next topic is scales of temperatures. Ladies and gentlemen, let me tell you that there are three temperature scales. One is called centigrade, which is also known as Celsius. Centigrade and Celsius refer to the same concept. The second one is the Fahrenheit. Fahrenheit. Few people are calling it Fahrenheit. Fahrenheit temperature is the actual word. And the third one is Kelvin. Commonly, these two are used very frequently all over the world for scientific experiment, and engineers are using it for different experiment. Now if you remember, in the first two lectures, I told you the 7 base unit in which we discussed that Kelvin is the uh, base unit for measuring of the temperature. And this centigrade and Fahrenheit are not the uh, uh, base unit for measurement of temperature. Ladies and gentlemen, one thing very important I am saying to you, in case of Celsius or centigrade, you can call it degree Celsius or degree centigrade. In case of Fahrenheit, you can say that degree Fahrenheit, whatever the value, for example, 100 degree centigrade or Celsius. In many parts of the world, centigrade scale is used for scientific and engineering purposes, and many part of the world including United States of America is using this, for example 90 degree Fahrenheit. Yeah, Fahrenheit. Ladies and gentlemen, you can never call a Kelvin is a degree Kelvin. That is absolutely wrong. You cannot say degree Kelvin. For example, if you are saying degree Kelvin, then it means you don't have any knowledge about the temperature scale. So be careful while using these uh, symbols. These, instead of writing the full centigrade and the full Fahrenheit, that is difficult. We are using different symbols for different scales. For centigrade, because it is starting from centigrade, and Celsius is also starting from C, so we are writing uppercase letter C for degree Celsius. And because Fahrenheit is starting from F, so uppercase F is used Fahrenheit. Kelvin is developed by a scientist known as Lord Kelvin, and on his name we are using this temperature scale. He is saying that Kelvin scale is used for a very low temperature measurement, so you cannot call it as a degree. No degree is involved. Why? I wrote it in the side note that the Kelvin temperature scale is an absolute scale, that is absolute zero scale. Measurement made using the Kelvin scale do not have degrees. Remember these. Now, because it is absolute scale, I have written here. So the question arises, what is absolute scale? I wrote it here. The absolute temperature scale is 1, in which the zero of temperature is equal to absolute zero. What does it mean? The coldest possible temperature at which there is no internal energy, that is absolute. The lowest possible temperature is absolute zero. And whenever a material is getting this temperature, it means that it is the coldest temperature ever observed, and that is only the ideal temperature. Practically it is not possible to get the absolute zero, which temperature at which there is no internal energy. What does it mean? Means, and the particle are stationary. At that temperature, there will be no internal movement. And when there is no internal movement, it means that there is no energy in the particle to move freely. They are freeze. So it means that at that temperature, internal energy of the particle are stationary. Absolute temperature is measured in Kelvin, not in degrees. So it is absolute zero. What is absolute zero? The temperature at which the internal energy of a substance is zero, means that there is no movement of the particles, and that will be stationary. So such a lowest temperature can be measured in Kelvin. So there are three scales of temperature, in which one of them is centigrade or Celsius, the second is Fahrenheit, and the third one is Kelvin. First of all, we are dealing the centigrade scale. What is centigrade or Celsius scale? There are two fixed points of centigrade scale, and those two fixed points, as I discussed earlier, that these 2 points are ice point and steam point. Ice point is also called the freezing point, and steam point is also known as the melting point. Ladies and gentlemen, what is ice point? The lowest fixed point, that is the temperature of pure melting ice. If there is pure water, if there is mixture of water, you mixed with it either the salt or sugar or any other substance, then it will not be a pure, and then zero will not be the absolute, zero will not be observed as the correct scale. So you have to take the pure water which is free from any impurity. It is assigned as 0 degrees Celsius. How we will find this? That is our next topic. But generally, I am telling you that in centigrade scale, there are two fixed points. One is called ice point, which is assigned as 0 degrees Celsius. Now, the steam point, the upper fixed point, this is the temperature of dry steam from water boiling at a pressure of 1 standard atmospheric pressure. There will be no increase or decrease of pressure. If you are increasing the pressure, for example, if you are calibrating centigrade scale at a very high altitude where there will be a low pressure, then you will not get the correct calibration of the centigrade scale. Similarly, if you are going below the sea level, there will be a high pressure, then it means that you again won't be able to calibrate that temperature scale very precisely. So it is important that 1 atmospheric pressure must be the pressure at which you are getting the steam point and also the ice point, because pressure is changing the melting and freezing points of a substance. We will discuss that in the upcoming lecture, but for the time being, you have to remember these things. Okay, we learned, the teacher told us in general that there are three steps to construct a temperature scale. We got those points. And we also learned that scale of temperature are centigrade, Fahrenheit, and Kelvin. So next is practical work. How to construct these scales of temperature practically. For that particular purpose, we are performing two different experiments, and the topic name is calibrating a thermometer. We have to provide the determination of ice point, because we have two fixed point ice point, and now it is the turn of practical work. For that we are taking a funnel, that is a funnel in which we are putting ice cubes, small ice cubes, and then inserting part of the stem and the bulb, which must be inside the ice cubes. Now, ice cubes might not be in contact with the stem or bulb. So what actually we are doing? We are getting ice shaves, that is very mixture, fine grain of ice put in it. So if cube are not in contact with the stem or of the bulb of thermometer, this ice shaves will make it sure that the cubes or the ice is in contact with the bulb and stem of the thermometer. Okay, determination of ice point we are talking about. So first we have to immerse the bulb and the lower part of the stem of the thermometer into a funnel containing pure melting ice. The ice must be pure. I told you what is pure. The second step is to ensure that the contact between the bulb and the ice is good. Ice shaving should be used. The mercury level in the stem should be just above the surface of the ice. It should be above the surface of the ice. Ladies and gentlemen, there must be what? They are saying that the mercury level should be above the surface of the ice, which is in this case is this area. This must be above. Why? Because it will come down. If it is already in the down portion, it will not go down further, and as a result you won't be able to get the precise answer. So for that particular purpose you have to do what? You have to do that, make sure that the mercury level is above the ice. When it is cooling down, it will come down. Uh, the third and very important, you have to observe the mercury inside the uh, thermometric tube, and when the mercury level in the stem remains steady, it will come down, it will come down, it will come down, you will observe, but there will be a point which will remain steady and it will not move down further. So you have to note that point, and that point will be the ice point, and you have to assign a value of 0 degrees Celsius to it. Let me take this thermometer here. So you are observing that the mercury level is coming down, and at this point they are not moving further down. So you have to mark that point just like I did here, and then you have to assign it 0. Now that was the whole story of determination of ice point here. When the mercury level in the stem remains steady, after some time a mark is made at that point of the stem, which is ice point, that is 0 degree Celsius. Now we are going to discuss what? We are going to discuss the second part. We mark the ice or freezing point of pure ice. Now we are determining the steam point, which is also known as the upper point or the boiling point. For this, we are having a container in which there is a water, there is a fire, heat is produced, and it is given to the molecules inside the water, and they will start boiling. But before that, there must be a thermometer, and it will be hanged, and it will not touch this container. It must be above, and there must be steam here. So I am writing steam on this side, and on that side of container there will be a steam produced by this boiling water, and this bulb and stem will be somewhere immersed inside this steam. Now on this side there is a tube from which it will get the steam out, and on this side we will have a manometer which will measure the external pressure. It should be 1 atmospheric pressure. Let us elaborate. Insert the thermometer into the apparatus. These are the apparatus. The bulb of the thermometer should be above the boiling water. It shouldn't touch. That is very sensitive bulb. If you are touching it with that container, it will be broken, and the mercury will spread all over, which is dangerous. I told you yesterday. Okay, should be above the boiling water. The stem of thermometer should be protrude above the top of the apparatus. It should be held above the top of the apparatus, so that it is not touching any part of the apparatus. A manometer should be included to ensure that the pressure inside the apparatus is the same as the atmospheric pressure outside. That is why we are including manometer. It is not that the outside pressure is something else and the inner pressure of the apparatus is something else. There is a difference between the two pressures, so we won't be able to get it right. So for that particular purpose, we are making sure that the internal and external atmospheric pressure is the same. And you know that manometer is a device which is used for uh, measurement of the pressure. Okay, the second part, apparatus is same. The third part, when the mercury level in the stem remains steady as just was the case in the determination of ice point. The mercury level will go like this, up, up, up. It will expand due to thermometric property, which is one of the property that it is expanding linearly. And when it reach a certain point, for longer time it will remain steady and it will not change. You are providing the heat, steam is there, but the mercury level is not changing for a specific amount of time. So when the mercury level in the steam remains steady, after some time a mark is made and assigned a value of 100. For example, this is of 100. So in this particular case, you can find the two lower points and upper points. Now you have to measure this length, whatever length is this. For example, it is 1 meter, which is not possible. Thermometer is of not 1 meter, but for example, for your understanding, I am saying that it is 1 meter. So you have to divide 1 meter in equal parts. In this case, we have to divide it by 100 equal parts in this, and each part is called 1 degree Celsius. So in this case, you can calibrate an thermometer, and then we can use the thermometer. That's it for today, ladies and gentlemen. Tomorrow we will come with a new topic with a new energy. Thank you very much for watching. Allah Hafiz.